A box contains both red and black checkers. 4 checkers are drawn out. How many different possible outcomes would result in exactly 3 checkers being red?
Thank you. Excellent. See, wherever I ask Alex, he always immediately 1 second. This is very important. Careful, and his score improve. It's related to everybody. Let's do this. Number 4. You have many questions like this on the test. I'll make you expert in probability. So what we have, a box containing both red checkers and black checkers. 4 checkers. We have what is given. 4, we have black and red, red, red. Overall 4. Okay. How many different possibilities, possible outcomes would result in exactly 3 checkers being red? Well, I show a couple different ways. It's number 4. For instance, we have 4 shelves. 1, 2, 3, 4. Okay. For instance, the first is black, and 3 checkers are red. Or 1, 2, 3, 4. I can have red, black, red, red. Or we can have red, red, black, red. Or red, 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 black. And you see B is moving from this corner to this corner. If I count, I will find, they ask you how many. We have 4. Total 4. Okay. Who understand this 100%? 100. 100. Who has question, ask me. Let me solve another smarter way, but also a good way. The best, probably. I will remind you the formula. Actually, what they ask you about? They ask you number of combinations, right? And we started with you number of combinations. C, number of combination from n elements by r equals n factorial divided by r factorial multiplied by n minus r factorial. This second way. I just remind what is factorial. For instance, factorial of 3 means 3 times 2 times 1. Or factorial of 4 equals product of all these numbers, starting from 4 up to 1. You name a factorial. And this combination formula. How to apply this? The second way. We have combination from 4 elements grouped by 3. How many we have? This second way. Just plug into this formula. What is it? This is 4 factorial. Divide by 3 factorial. Multiply by 4 minus 3 factorial. Or equals 4 factorial is 4 times 3 times 2 times 1. I will not show simplified way. This is 3 times 2 times 1. This 4 minus 3 is 1 factorial, is just 1. Now look at this. 3, 3 cancel out, 2, 2 cancel out, and you get 4. Whatever, you also use this combination formula a lot for this test. Okay, combination. How many elements of from entity of 4 elements by 3 you can get? We did it with you, remember? Yes.
How did you get 3 groups?
They ask you by 3. Read the question out loud, Lina. How many 3 reds from entity of 4 you can get? You see this? This is a question. How many different possible outcomes will result exactly 3 checkers being read? They ask you 3.
Thank you.
Welcome. Anybody else? Who has questions? Ask me questions. So good idea to have it, to know both ways, because when you finish this test, you have extra time. Usually my students have extra time, and you check your work second way. I tell you joke. One student who loved probability, he decided in multiple choice test, instead of solving problem, he took a coin, a quarter, and tossed this, okay? And he tossed what the probability of a multiple choice to get this or this or this. And professor thought he finished the first of this test, and he would probably get no good result. When everybody finished, he kept tossing this coin. And professor asked, "What are you doing? Why so long?" He said, "I'm checking my work." You got the joke? Okay, good. Number 5. Number 5. Who would like to read? Did not read. Kevin. Number 5, please. 2 seconds.
A number between 1 and 10 is chosen twice. How many different ways might the same number be chosen both times?
Thank you. Nice reading, fast and nice, with intonations. Number 5. What they said? A number between 9 and 10 chosen twice. So if you have star, 3 combinations, star. The first time you have either 1 or 2 or 3 or 4 or 5, 6, 7 or 8 or 9 or maybe 10. It's the first time. I don't know which one, either one. So the question is, how many different ways might the same number be chosen both times? The same. What is it? You can have any of these, let's say 1, 2, etc., up to 10. Like we did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we care about the same only one. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10. This is the second time. Now count. We have 10. If you count all this, 10 times. If this one, this also supposed to be 1, etc. 3 combination. Who understand this 100%? Who has questions?
Dr. Farber,
Yes,
may I go to the bathroom?
sure. More questions, students?
Dr. Farber,
Yes.
my question is, can I read the next question?
Yes. My answer, yes, Georgie. Read next question.
Okay. A number between 1 and 10 is chosen twice. The sample space for the results includes how many outcomes that are even numbers followed by prime numbers.
Okay, thank you. Very nice reading, Georgie. Number 6. Tree combination is a great way to illustrate this understanding. So number 6. What number we have between 1 and 10? If you have this is 1 and 10 number between this my solution set, these numbers. And the sample space for results includes how many outcomes that even number. Okay, let's write even number. This is star, and this even. What even numbers do we have? 2, 4, 6, 8, 2, 4, 6, 8. Between these, right? Number between 1 and 10 is chosen twice. And the second, the sample space for result, how many outcomes that even number follow prime number. Prime number. Okay, what prime of number you have here? Either 2, if we're talking about prime, or 3, or 5, or 7, right? So far so good. 2, 3, 5, 7. For instance, if you have this even, it could be either 2, or 3, or 5, or 7. In the same, related to each of these nodes. Since we have 1, 2, 3, 4, 5, okay? We have 5, yes, 5. We have 5 even, and 4 prime. According to fundamental counting principle, total would be what? 20. For instance, you pass to Stevenson, and you have 5 pair of different shoes, and 4 different ties. And you wonder how many possible combinations you can have. 5 times 4, which is 20. I just make analogy for this. We did many times. So far, so good, students. Any questions? Understand 100%. Okay, good, good, good. Next, if you don't have any questions, let's number 7. Victoria, please.
I got C.
No, read the question, please, first.
2 6-sided dice are rolled. How many different outcomes for the 2 dice would result in a total of 7 being rolled?
Thank you.
Got C as in cat.
But I give you answer already. That's I ask you only to read the question, okay? If I did not give you the answer out at the beginning of class, I would ask you what you have. Nice reading. Number 7. Again, 2-sided dice. You have any dice? You have any die like this. It has 6 faces. Every die, right? From 1 to 6. From 1 to 6. use three combinations. Start. And the first, you have the first. Either one, we have 2, 3, 4, 5, or 6. What is my goal? How many different outcomes would result of 7? Goal to get 7. 7. To get 7, this is supposed to be 6 second time, because 1 plus 6 is 7. This would be 5. The second would be 4. This would be 3. This would be 2. And this would be 1. Okay. So how many of them? Is 6. 6. 3 combinations. Okay. Good. Let me cross it out. This. I explain everything. Number. Any questions so far, students? Okay, we do not finish. We have time. Brenda, would you like to read number 8? If you're ready for
Okay.
today. Yes, good.
Okay. A stack of 20 cards are numbered 1 through 20. If the cards are drawn from the stack until the third card is drawn, how many different outcomes will result in the third card being drawn on the third draw?
Okay, thank you. Very nice reading on time. A+. Let's go through number 8 together. Again, use the combination to solve this problem. 20 cards. This is number 8. Let's say this is the first, the second, the third card, the fourth, etc. And the last one, ellipsis, the 20th. Why? Because we have 20 cards. What else do you know? If cards are drawn from this stack until 3 cards is drawn, this until 3 cards is drawn, we're talking about this 3. How many different outcomes would result in the 3 being drawn on the third draw? Can we draw in the 3 in the first time? Students, what do you think? Question. Who will answer my question? Nathan, can I draw 3?
Yes.
No.
Wait, there's 20 cards. Why can't you?
Because, read the question, Nathan, again.
Stack of 20 cards are numbered 1 through 20. If cards are drawn from the stack until the 3 card is drawn, how many different outcomes would result in 3 being drawn on the third draw? Oh, can't be the first draw.
Okay, you see these cards, big cards. And according to this business rule, when I get 3, I will stop. You see? So I can get 3 the first time. If I get 3 the first time, I will not keep taking this card from this stack, right? Makes sense? So the first time I cannot get 3 for sure, because 3 is supposed to be only the third time. Since I have only 20, for the first time I can take any cards but not 3. I can have only 19 cards, because 3 is eliminated from this stack. To understand, this is key thing, students. Key thing. I supposed to stop this cycle when I get 3. But in order to have 3 options, I can't get 3 on the first time. No way. Now I can get, let's say I get 4. Can I have 4? Yes. So 4 already taken without replacement. That's why for the second position I can get 1 over 18 cards, because neither 3 no 4 can be over there. 4 is taken, let's say, and 3 is supposed to be over there. How many 3s do we have, students?
Only 1.
Only 1. Now, like we did today, fundamental counting principle, just multiply the 3 numbers. If you multiply this, I will get 342. Check mark. Is it a difficult question? Which grade you study multiplication 19 times 18? Tell me.
Second grade.
Second grade, yes. Only question, all probability question from point of calculation, not complicated at all. You have to only feel it from inside. How to feel it from? Just practice. This year they have many questions like this, many questions. Some students get like, I have this list of questions a lot. So I make you professional. Who has question about this question? Ask me. Who understand 100%? Raise your hand. 100. Ryan, Rebecca, don't relax. Rebecca, everybody. David, Emilia, Yuri, Kevin, and Rebecca. Why we don't have break? What do you think? We don't have break in order you concentrate. You must concentrate. Wherever you work, we must concentrate. It's where it's supposed to develop this skill. This was number 8. Let me finish this. We have time. I want to go through number 9. Elizabeth, would you like to read it? Number 9.
Dr. Farmer,
Yes.
may I go to the bathroom?
Yes. Don't forget to come back, Georgie.
Sorry, my mic wasn't turning on. Number 9 in statistics and probability, right?
Yes, it is.
Sorry. A target has 4 rings on it. How many different ways might 2 arrows be distributed on the target?
Okay, you have a target. Number 9. Let's make this schematical. 1, how many they said? 4 rings. 2, 3, and 4. And then 4 rings. How many different ways 2 arrows be distributed on 2 targets? For instance, the first time, we have 2 targets. Look at this. The first time, when I throw my dart arrow, it can be any of 1 of these 4 rings. Which one? I don't know. 1 out of 4. Which one? I have no idea, and I don't care. Compared to previous problem, which was without replacement, you took card, you do not put back. Can I throw the second dart to the same target, to the same place? Yes. So second time, I also can have 4 options. Pretend the first time I get this over there, and the second I also get this. Okay, no problem. It could be any of 4. And according to fundamental counting principle, this is 16. And this question was asked by 8 students. 4 times 4. Okay, it's question of experience. I guarantee you'll be very strong in this. for this Gugagaka question? Can you see Gugagaka question? Yes? Who understand? Raise your hand. Okay, what about my friend Ryan? Yes, good. Rebecca, more careful. Let me put it this way. I have been teaching in many continents for 47 years. Online this year, I have been teaching for 17 years. It's not like we just started online when you study in your beautiful school. I wrote many dissertations. One of dissertation was work for an diploma in teaching online. My dissertation for teaching online was comparison analysis of teaching online using method of images and in classroom. Okay, so this is my profession. This last year, students online who took this class, they get even higher scores than students that took class in person. My point, if you know how to teach online, this is a great opportunity because you have more time asking questions, not wasting time for commuting from online or from New Jersey for Connecticut, and you can get better even score. Only question, you must work and follow my my method. Well, any question? Number 10? 10. Yuri raising hand, right? Yuri?
No, sir, I forgot to raise it back down.
I don't understand this. Just read number 10. When I ask who read, you have no sorry, just read it.
If 5 different players have to be placed in 5 different positions on the team, how many different ways might this be done?
Okay, thank you. How many students we have for this question? 7 students. Wow. Good. Number 10. How many students? 5. 5 students. 5 students can be placed in different positions on the team. So this team consists of 5 students. This is the first position, the second position, the third position, the fourth position, and the fifth position. For this, for the first position, I can take any of these 5 people, 1 over 5, 1 out of 5. Since 1 already taken out of 5, for the second position, I can have only 4, 1 out of 4. Since 2 people taken from this entity, for the third position, I can have only 1 over 3. Since 3 taken from this entity, for the fourth position, I have 1 out of 2. And finally, for the fifth position, I have only 1. According to fundamental counting principle, 20 times 3 is 60 times 2, 120. Is 120. So we went actually from all these probability questions. And can you see this easy and fun? Easy questions, all probability. Well, we are out of time. I practically explained you almost everything except for word problem.